Hi everyone, welcome to another episode of Our Labs. Sorry for the wait. Do you know how busy the holiday seasons can be? I have a bit of a cold, so my voice may seem a bit scratchy. I got another Tinker crate. This video, I will be building a color mixing LED light source. Next video, we will talk about how the LED changes color and the science of color. This video, however, we will focus on how to build a light source which uses a color light emitting diode. In other words, LED. Because the LED requires a current of electricity to flow through it, the Kiwi Tinker magazine introduces the concept of electrical voltage, current flow, and resistors. The kit comes with resistors, diodes, and batteries, which we will assemble into electrical circuits to create different colors of light. This is what an LED looks like. My grandpa is a retired professor of engineering, so he was happy to give me a mini lecture on the subject. I'm going to share some of the things that he explained to me. We have to apply a voltage of electricity across the diode to make current flow through it. This is a simple drawing of how an LED works. The LED is a solid-state device designed so that when a positive and a negative charge come together inside the crystal, light is emitted. A simple electrical circuit to power a diode looks like this. The battery is rated at, each battery is rated at 1.5 volts of direct current, in other words, DC. However, if we apply the full voltage to the LED, the current flow of electrons might be too high and it could be damaged. So we have to add resistance to the current flow by adding resistors to the circuit. These are resistors. The resistors do just what the name suggests. They resist or reduce the current flow by causing a voltage drop, which will subtract from the 1.5 volts of the battery. The amount of resistance a resistor produces is measured in ohms. I will use a multimeter to measure the resistance values of the two different colored resistors provided in the kit. The current flowing through a resistor is measured in amps. There is a very simple formula that relates current flow, A, voltage, V, with resistance, R. A equals V divided by R. That means that the amount of current, A, that will flow through an electrical circuit increases as the voltage V increases and decreases as the resistance R increases. Quite logical, don't you think? This shows how the voltage drop across the resistor reduces the voltage applied across the diode and limits the amount of current that will flow through the LED. So now we will assemble the kit. Thanks for joining me, Grandpa.
You're welcome, Robbie.
Let's see.
So this is going to be a neat instrument once you get it done.
It should be.
So what's the next step? You put in one thing for the wire. Do we put this thing on next? Where are we going here? Where are we at on our instructions? Oh, we're on B here, right? Or no?
No.
We're still up here.
Yes.
Can we slide this down so we can see?
Yes. Next step are these two. And where are the other two guys? There they are. This goes to green. Okay, now that we've prepared the base, it's time to wire the circuit. Okay, first we need to take the T-bar and through the base's left slot. Okay, and then so we need to flip it around. And then stick this one here. And then right there. Yes. Okay. So this is the front side view, and this is the underneath. Okay, now let's test it out and activate it. Oh, it's green. Now let's see. Green, blue. If we move this out, it's completely blue. White light.
Why is it white?
Next week.
Right. Next week we'll talk about why it's white.
And it's yellow. Mix all three together, you should get white.
Okay.
And get none, you get black.
Okay. So we're going to use what's called a multimeter. It measures current, voltage, and resistance. So I have it set it on 2K, which means 2,000 ohms. And I will hold the brown one, and you measure. What do you measure?
76.
76. That's the brown ones. Let's measure the blue ones.
$131.
So just about twice, right?
Yes.
So the blues have almost twice as much resistance as the brown ones. And those are in ohms, right?
Well, check out our next video to see how this changes color. If you have any other suggestions, write them in the comment section below. Bye! See you next time.